Hello viewers, I am Dr. Little from the Department of Physics, Stella College. Happy to welcome you all to a talk on lasers and its fundamentals. What is called a laser? It's an acronym, stands for light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. Why we should know about lasers? Because lasers have become part of our everyday life. Here you could see so many applications. I have listed a few. In medical field, lasers are used for eye surgery, skin treatment, and in manufacturing industries for welding, cutting and all, and entertainment industry using lasers for making shows. You can see lasers in lidars used to measure the surface of the moon or the surface of the planet where they want to land their space vehicle. And in the wars, they use, in militaries, they use lasers like this. Lasers have become part of our life, so it is nice to know about its fundamental principles. All of us know matter is made up of atoms. The structure of the atom can be represented like this. The nucleus is shown here. The circular orbits around the nucleus, they are called orbits or shells or the energy levels. So this is the first energy level, this is the second, third, fourth and so on. You would have studied in the lower classes that in the first orbit 2 electrons will be revolving around, in the second orbit 8 electrons, third can have 18 and the fourth 32 and so on. This is the structure of the atom. Now let me say certain phenomena. What is absorption, what is emission, what is spontaneous emission, stimulated emission, like that. So what is absorption of radiation? Now let us just ignore the presence of nucleus, just take the energy levels alone. Here this electron is in the first orbit. Suppose when the atom is in the ground state, by some means if the atom absorbs energy and the atom gets excited, that means its electron from the first orbit gets excited to higher energy level. This is because the electron of the atom has absorbed certain energy. This is what called absorption. So here I represent the energy levels E1, the second, the higher energy level as E2. The difference between the energy levels can be written as delta E equal to E2 minus E1. So this is the lower level, this is the lower level and this is a higher level. Suppose the electron in the first orbit absorbs energy, it will excite to the higher energy level. So this electron can absorb energy if the energy is equivalent to this one only, because these are the energy levels. The space in between them is called forbidden energy level. Suppose if the incident photon has energy lesser than this delta E value, this electron will not absorb that energy. So it will absorb the energy when it is equivalent to delta E only, so that it could go to the next higher energy level. So this is what called absorption. Next let me tell about emission of radiation. So to understand the principle of lasers, we must know all these basic facts. What is called emission? Now here I have, in the figure I have shown, in absorption, electron in the first orbit by absorbing the energy gets excited to the higher energy level. So let me say the electron is in the third energy level. Now spontaneously after the lifetime gets over in the excited state, the electron jumps back to the original level, the lowest energy level, by emitting the excess energy with it. So this is what called emission. Electron in the excited state, when it returns to its ground level, it will give off the excess energy in the form of a photon. This is what called emission, and this type of emission is called spontaneous emission. So in terms of energy level, I have shown here energy level 1, 2, the electron in the excited state, when it returns to its ground state, it emits a photon. So the emission of photon will be in random direction. Anywhere it could be. Okay. So the photons are emitted in random directions and at random timings. So the rays will be incoherent. Emitted photons will have different wavelengths and phases, resulting in coherent light. So you will ask, what is coherent light? We will study in slowly. So here the electron from the higher energy level, when it jumps to the ground level, it emits a photon in any direction at any time. So the emitted photons will not have same wavelength, they will be having different wavelengths, and they will not have same phase also. Such emission of photons, we call it as incoherent light. So let me compare here incandescent light sources and laser light sources. The light sources which we use to illuminate our rooms are all called incandescent light sources. For example, this room is lit by these lamps. Of course, it has white light. If it is passed through the prism, you can see multiple colors. Okay, so the light rays will have many wavelengths and they are all emitted in different directions, and due to this incoherent light, the entire room is getting illuminated. Suppose if we have a laser light, they are called monochromatic. That means the emitted light will be having only single color. So this room is lit by this white light. White light has Vijayawada colors. Okay, when dispersion takes place, this white light gets split up into its constituent colors Vijayawada, right? So this way it becomes, this incandescent bulbs will be emitting many wavelengths, whereas laser light will be emitting only monochromatic light. That means it has single wavelength and in one direction only, and all of them will be coherent. So this picture shows the light rays coming from the incandescent bulb will be not in having same phase and same wavelength. So it is called incoherent light rays, whereas from the laser source, the emitted photons will be having all moving in the same direction with the same wavelength, and they all will have same phase. So you can call this beam as a coherent light. Now let me explain one more type of emission. This is what called stimulated emission. So for laser to work, we need this stimulated emission. So in lasers, something different takes place. Okay, let us take the help of a diagram. Now let us say that the electron is in the excited state. So when the electron is in the excited state, at that time, if a photon having energy equal to the difference between these two energy levels interact with this electron. Okay, so electron is in the excited state. Now a photon whose energy is equivalent to the difference in the in these two energy levels, if it comes and interacts with this electron in the excited state, this electron absorbs this photon also. Now it is too much for this electron to hold the energy. So what this electron will do? It will emit the photon whose energy is equal to difference between these two energy levels and the incident photon also. So you are getting two photons. This is what called stimulated emission. This stimulated emission emits by which the emitted photons will be traveling in the same direction and they will be having the same wavelength. So you can say call them as to be coherent in nature. So stimulated emission takes place only when the photon interacts with the electron in the excited state. Okay. Absorption takes place when the photon interacts with the electron in the ground state. But stimulated emission takes place when the photon having energy equivalent to the difference in energy levels is interacting with the electron in the excited state. So this is what called stimulated emission. An incoming photon with the same energy interacts with the excited atom, and then the atom releases photon identical to the incident photon. The emitter photons have same wavelength, phase and direction as the incoming photon. So the emitted photons cannot be emitted in all directions. The emitted photons also will travel in the same direction as that of the incident photon. So you can call them as a coherent light. Now one more part we must know. This is called population inversion. Normally most of the atoms will be in their lower energy levels. At normal room temperature, the atoms will be at the lower energy state, or you can call them as ground state. For a laser to work, we need more atoms in the excited state, because stimulated emission only producing coherent light. Coherent light is called laser light. So this coherent light, to get, the photon has to interact with atoms or the electrons of the atoms in the excited state. So we want more and more atoms to be in the excited state. So this condition of transferring more atoms from the ground state to the excited state is called population inversion. This process of achieving this condition is called pumping. Pumping means transferring the atoms from the ground state to the higher energy level, so that the incoming photon can interact with the electrons of the atoms in the higher energy level for stimulated emission to take place. Right. You can see in the first picture, atoms are in the ground state. Now, the incident photon interacts with the atoms in the ground state. So, the atoms are getting transferred to the higher energy level. So, this is the first process because of the interaction of the photon with the atoms in the ground state. Now, the second process is coming. Atoms are taken to the higher energy level. This process of transferring the atoms from the ground state to the higher energy level is called population inversion, and this process is called pumping. So normal state, most of the atoms will be in the ground state and few only will be in the excited state. Under population inversion, most of the atoms will be in the excited state, only one or two will be in the ground state. So a system in which population inversion is achieved is called an active system. Now slowly we are coming to the working of laser. So first of all, for lasing to take place, we need to have active system. What is called active system? A system in which the atoms are transferred to the excited states, not in the ground state. So this is called active system. Now, there are some methods to do this pumping which take atoms from the ground state to the excited state. They are optical pumping. In ruby laser, this method is used. Electrical discharge pumping method. This is used in helium neon laser. Direct conversion. In semiconductor lasers, directly the conversion will be taking place. And chemical reaction, so which is used in carbon dioxide laser. So pumping methods. What is pumping? Pumping of atoms from the ground state to the excited state is called pumping. There are 4 types of pumping methods: optical, electrical discharge, direct conversion and chemical reaction. Now we need one more condition called metastable state. what is called a metastable state, an energy level in which an atom in the excited state can exist for a little longer time. This is what called metastable state. An energy state with a long lifetime is known as metastable state, which is having the lifetime the excited atoms. So if the excited atoms can stay a little longer in certain states is called metastable state. How can we create this metastable state? So we add some impurities to the actual active medium. So by introducing impurities into the active medium used in the laser, the impurity atoms energy levels will be in between the energy levels of the actual active medium, or you can say the energy levels of the impurity atoms will be in the gap between the energy levels of the actual active medium, okay, enabling the population inversion necessary for laser operation. So we need a metastable state. That means now atoms are taken to the excited energy level. Their lifetime is limited to 10 power minus 8 seconds. So within that time, when that time gets over, the excited atoms will return to the ground state by giving out spontaneous emission. Now there should be some technique so that these excited atoms, instead of returning to the ground state, they go to some other levels where they could stay a little longer. For example, 10 power minus 3 seconds. Then that states are called metastable states. So this metastable states will promote stimulated emission, which is necessary for laser to function. Okay. So let me say ground level is shown here, the metastable energy level and the higher energy level. So just by adding some impurities, you are creating an energy level in between the energy levels E0 and E2. So this is called metastable energy level, metastable state otherwise. So what you do, the ground level is E0 by pumping. Pumping could be optical method or electrical discharge. The other methods are also there. For example, by optical method, you send some photons which interact with the atoms in the ground level and they are transferred to the higher energy level. In the higher energy level, that excited atoms after some time, for example 10 power minus 8 seconds, they return. Instead of coming to the ground level, they go to the metastable energy level. What happens? Let us now see. So first, the excited atoms from the higher energy level jump to this state, which is called metastable energy state, by spontaneous emission. Now, from metastable, in the metastable state, the atoms can stay little longer. Okay. Now what happens? From the metastable state, when the time 10 power minus 3 seconds gets over, the atoms are transferred to the ground state by stimulated emission. What happens here when the atoms are in the metastable state? We send some photons whose energy is equal to the energy level, equal to the difference between the energy level E1 and E0. So what happens? These photons interact with the atoms in the metastable state. So they absorb, they can't hold that. So what they will do? They will emit the absorbed photon as well as the excess energy what they possess, and they return to the ground state, causing stimulated emission. You can see the stimulated emission. So here two-step process is taking place. First of all, atoms from the ground state. Atoms from the ground state are transferred to the excited state E2. Now from the excited state, by spontaneous emission, atoms are transferring to the metastable state. From the metastable state, when they are in the metastable state, some photons interact with them, promoting the stimulated emission takes place. As a result, you can see a lot of photons emitted, and the atoms from the level metastable state E1, they jump to the ground level E0. So normal excited energy levels will be having lifetime of atoms will be 10 power minus 8 seconds. In metastable states, the lifetime becomes 10 power minus 3 seconds. So initially, from the excited state, these excited atoms return to the metastable state by spontaneous emission. From the metastable state, when the atoms are transferred to the ground level, they emit photons which travel in the same direction, which have the same wavelength, which all will be in same phase, thus creating a coherent light rays. This is called laser light rays. Yes, a small comparison. Normal excited state, metastable state. When there are no impurities, you have ground level and the excited state only. When there are some impurity atoms in the active medium, you have excited state and metastable state also. So in excited state, the life of atoms will be short lifetime, 10 power minus 8 seconds. In metastable state, the atoms can have a little longer lifetime, which is equal to 10 power minus 3 seconds. And then when the atoms are in the excited state, they will undergo rapid decay. Whereas when the atoms are in the metastable state, their decay will be delayed because they have little longer lifetime. And the excited state will be less populated, whereas the metastable state will be more populated due to the presence of impurity atoms. So, till now we have understood everything. Now it will help us to just narrate what is laser now. Main components of laser. There are three main components in the laser. First one is called active medium. In the previous two slides we discussed about active medium. That active medium could be solid. Example is ruby laser. It could be liquid laser. Rhodamine 6G dye laser is called liquid laser, and gas laser examples are helium neon laser and carbon dioxide laser. So active medium, the medium could be solid, liquid or gas. So this first requirement, we need some medium which is having atoms. Okay. So next, energy source. So we need optical method, excitation we said, or optical energy, optical method we said. So we need some energy source which transfer the atoms from the ground state to the excited state. Next is called optical resonator. The figure I am giving here. So there is a rectangular sealed tube would be there, which will be containing the active medium. Here it is mentioned as laser gain medium, and this rectangular cylinder is surrounded by, or two mirrors are kept on the right side and the left side. Then this combination together is called resonator or called optical resonator. So optical resonator, it has two parts. One is the active medium which is kept in a rectangular sealed box. The sides of the rectangular sealed box will be sealed with the two kinds of mirrors. One is the left side, the other one is right side, or I can say one is at the rear side and the front side. So this mirror will be totally reflecting. Any lights fall on the mirror, the light will be totally reflected, whereas the front mirror is a partial reflector. Some rays it will allow to pass, and most of the thing it will be reflecting back. So the name for this is called optical resonator. Yeah, laser means whether it is a solid laser or liquid laser or gaseous laser, it needs three components. One is active medium, another one is energy source, another is optical resonator. If any one is not there, it cannot act as a laser. Let me now briefly tell about the working of a laser. So, first of all, we need to excite the atoms from the ground state to the higher energy level, thus achieving population inversion. And by using the technique stimulated emission, we need to create photons and amplify them so that you get a laser beam. So here also you have 3 steps. First step is population inversion. Number of atoms in the excited state becoming more than the number of atoms in the ground state. So different methods I said, like optical pumping, like electrical discharge, direct conversion, all that will transfer the atoms from the ground state to the excited state. That is first thing. Next one, we need to send some energy and create stimulated emission. So stimulated emission, we are getting lot of photons. They will be very, very weak. Third step is that amplify or strengthen the energy level of these photons to get a strong focused beam. This is what called working. Pumping, optical pumping, stimulated emission and amplifying the emitted photons. That's what the working of a laser. So a simple picture helps us to understand. First one, you need optical pumping, transferring the atoms from the ground level to the the higher energy level. So optical pumping is over, which is leading to the population inversion. Now from population inversion, due to spontaneous emission, the atoms are getting transferred to the metastable state. When the atoms getting transferred from the metastable to the ground state, they emit photons. This is what called stimulated emission. These emitted photons will undergo amplification between the mirrors of the optical resonator, which will give out the laser beam. Lasing action. So the photons which are released by stimulated emission bounce back and forth. So they go and strike the mirror at the right side. It will be reflected back to the left. So at every reflection they gain energy more and more. They become more and more energetic. So the emitted photons by stimulated emission will undergo multiple reflections between this mirror and this mirror, and they become very strong and they come out of this mirror because this mirror is partial reflector. So when their energy is higher enough, it will pass through the second mirror, come out as a laser beam. Why we call it as a laser beam? They are all coherent in nature. Monochromatic, single color, single wavelength, high coherence, all of them will be traveling in the same direction, and high intensity. So we have got a laser beam from this laser. So this is what called lasing action. The emitted photons by stimulated emission undergo multiple reflection in the optical resonator cavity, and when their energy is high enough, they come out of this mirror as a laser beam. So in simple terms, we can tell when this lasing action is taking place. Okay. So first, optical pumping, transferring atoms from the ground level to the excited state. Next, stimulated emission should take place. That means they jump from the metastables to the ground state. So emitting lot of photons, and these photons undergo amplification between the mirrors in the optical resonator. Finally, we are getting a laser beam. A powerful coherent beam of light is emitted from the laser cavity. So I thank you one and all for listening to this fundamentals of lasers. I hope you would have enjoyed. If this part is clear in mind, you can easily understand the working of ruby laser, helium neon laser, semiconductor laser, whatever it may be. You can easily understand. So this fundamental you must understand. So I thank you for listening to me. Thank you one and all.